Rate limiting is like a bouncer at a digital nightclub. So just like a physical venue has a maximum capacity for safety, so online services can only handle a certain number of requests at once. So the rate limit is that maximum capacity. So you can picture like a popular restaurant that can seat like 50 people. If 200 people show up all at once, then chaos is going to ensue. There's not enough tables, the kitchen's going to get overwhelmed, the service is going to collapse really. So rate limiting helps prevent this digital chaos just by controlling how many requests can come in and how fast they can come in. And in automation terms, when your workflow sends data to like Google Sheets, for example, or posts to social media, or is requesting data, you're making requests each time. So rate limiting just says you can make 100 requests per hour or maximum 10 requests per second. It's just the service's way of maintaining order. And you can think of it like a ticket system at a deli counter. Everyone gets served, but in an ordered fashion, pretty much. You take a number and you wait your turn. Without that system, it's just a mob of people all yelling orders at once. Online services run on expensive servers, and they're going to cost thousands of dollars per month, if not more. So every request uses processing power, uses memory, uses bandwidth. And those are real resources that cost real money. So without limits, a single user could consume resources meant for thousands of people. So free tier users might wonder, why they can only send like 100 emails per day through an API. And it's because the company is essentially paying for your usage. So they limit free users to ensure that paid customers are going to get the performance that they're paying for. So it's kind of like a gym offering like a free day pass, but then limiting them to just off-peak hours. So rate limiting also blocks malicious attacks. So hackers will often try to crash services by flooding them with millions of requests over and over, usually called DDoS attacks. By limiting request rates, the services stay online for legitimate users. So it's protection against both accidents and also attacks. Companies calculate limits based on their infrastructure costs and their business model as well. So a startup might set lower limits to keep their server bills manageable when they're just starting out, but enterprise services are going to probably set higher limits, but then charge accordingly as well. And these aren't just arbitrary numbers made up. They're carefully calculated based on server capacity and just other general economics. Fixed window limits reset at specific times. So daily quotas typically reset at like midnight UTC, which is going to be a different time in Eastern or Pacific time. And if your limit is 1,000 requests per day, you get a fresh 1,000 exactly at midnight UTC, regardless of when you used yesterday's quota. Rolling windows work a little bit differently. So 100 requests per hour means any 60-minute period, not calendar hours usually. So if you make 100 requests between like 2:15 and 3:15, you can't make more until 3:16 when the oldest request falls outside the window. It's kind of like a sliding scale, always looking back exactly by 1 hour. Some services use monthly quotas that reset on maybe your billing date. So if you signed up on the 15th, your limits refresh every 15th. API keys often have lifetime limits around it. So maybe like 10,000 total requests ever for a trial key or something like that. And once it's exhausted, you need maybe a new key or a paid plan. Token buckets. Token bucket timing is going to add complexity as well. You might get like 10 tokens per second added to your bucket with a maximum bucket size of 100. This allows like short bursts above maybe the sustained rate. You could send 100 requests instantly if your bucket is full, but then continue at 10 per second, something like that. HTTP status code 429 means too many requests. So that's kind of the universal rate limit signal. So when your automation sees that particular code, it has to pause and maybe retry. It's pretty much a red light traffic specifically for API requests. Modern services return 429 instead of just a generic error. And response headers are going to contain rate limit intelligence sometimes, like X rate limit, will show your maximum allowed requests. X rate limit remaining, we should tell you what's left in your quota. And the rate limit reset provides a timestamp for when your limits refresh. So those headers should let you track your usage without hitting the limits. And then there's retry after headers. They're going to specify exact kind of wait times. If it says retry after 120, then you wait 120 seconds before trying again. So some services return this as an HTTP date instead of seconds as well. Your automation might need to pass and respect those instructions. Error response bodies often include human readable explanations. So Twitter is a good example. It might return like rate limit exceeded, the sentence, try again in 15 minutes. I think GitHub's API includes like documentation links in its error messages. So you just want to pass those messages to display helpful information in your automation logs rather than just generic like request failed errors. You want to implement request queuing with controlled release rates. So instead of just firing requests as fast as possible, you might want to create a queue that releases one request per second. So in NAN, you can use the wait node to set like wait for a specific time interval between each HTTP request, and that's just going to spread your load evenly. You might want to batch operations. That's going to reduce your request count dramatically as well. So instead of updating spreadsheet cells one by one, maybe you can collect all of the changes and update an entire range in a single request. And many APIs offer batch endpoints that you can use. So I think SendGrid lets you send like 1,000 recipients in one API call versus 1,000 individual calls. And caching prevents redundant requests. So if you're fetching user profiles that rarely change, you might want to store them locally and reuse them for like 24 hours. And you want to check timestamps as well before you're making fresh requests, because that can cut your API usage by 80-90% for reference data. Circuit breakers are really good. They prevent kind of cascade failures. So after hitting a rate limit, disable that integration temporarily rather than just retrying endlessly over and over again. You want to set like a circuit open flag that kind of prevents new requests from like 5 minutes, then test with a single request before resuming a normal operation. That's just going to prevent you wasting your quota on requests that go nowhere. They're doomed. You want to log every API request with timestamps to diagnose limit issues. You want to count requests per minute, maybe per hour, per day. You want to compare it against your documented limits. You might be making more requests than expected due to like retries or loop errors that you've got. Visualization helps spot patterns as well. So you want to implement like graduated retry delays to recover gracefully from something. So maybe you retry after a second, then maybe 2, 4, 8, up to a maximum of maybe like 5 minutes. And this is kind of exponential back off, and it prevents hammering services while still recovering as quickly as possible. And you can add jitter, which is like random milliseconds, to prevent synchronized retries. So you want to split the load across multiple credentials as well when single account limits are insufficient. So you might want to create 3 API keys and rotate between them. You could use different services for similar functions. So you might want to alternate between SendGrid and Mailgun and Amazon SES for your emails, perhaps. You know, that's going to multiply your effective limits. And you want to set up monitoring alerts before you hit your limits. So when you reach, say, 80% of your quota, send some notifications. You know, this is an early warning that's going to let you investigate and adjust before workflows start to fail. And if you can, you want to include automatic throttling that slows down request rates as you approach your limits. That's just going to ensure that whatever critical automations you have running can complete successfully, even if they run a bit slower.